Okay, hey, it's me, Destin. Welcome back to Smarter Every Day. Now, a lot of the pictures you see from the International Space Station come from the cupola on the inside here, right? So the cupola is on node 3, is that correct?
Node 3.
Node 3. All right, so this is astronaut Don Pettit. You may know this guy. You've done all the city tracking.
Yeah, I've done a lot of cities at night, and then the nighttime aurora and time-lapse sequences of Earth. Many of those that you see have been done in this module when I was at the helm of the camera.
He's the junk. Let me just say it that way. You're the junk when it comes to space photography, right? Can you say that? Say I'm the junk?
No, I can't say that because I get too embarrassed.
I'm gonna meet you on the other side, okay? So, seriously, he's the junk. Like all the really cool aurora stuff, Don's the guy that took it.
Now this is a cover.
Okay.
So we call it a shutter, and it protects the windows from micrometeorites.
Okay.
The shutters are closed, the windows are protected, and also thermally insulates the windows from the radiation environment of space.
So can you shut these things from the outside?
No, you can open and close them from the inside.
Oh, okay, wait. On the inside, you're throwing a lever or something.
Yeah, you're turning a knob.
And it's
opens. Yeah.
On the outside.
On the outside.
How do you do that and maintain a pressure seal between them?
O-ring type seals.
No, you don't.
With a rotating shaft. All our hatch seals are O-ring type seals.
Yeah, but how? My brain's
up here. Let's go inside. We can see it.
Okay.
Watch your head.
All right. Oh.
Oops, thunk. So you have a whole series of O-rings in here, and a shaft that you rotate.
So I mean, like on the space station, how many of these would you have?
7, because we have 7 windows.
What happens if you get a leak on that?
Then you have a leak.
You just have a leak,
and what you would do
is
you
lose air.
Yeah, you would probably seal the whole cupola off, and then there's probably a plan, I don't know off the top of my head, but there's probably a plan for replacing the mechanism. Might require a spacewalk.
So my question is, how can you operate a lid on the outside of the space station by manipulating something mechanical on the inside of the space station without losing air pressure?
It's called real good engineering.
Okay, you heard Don Pettit. He said that it takes a really good engineer to design this sort of thing. I'm told the guy quit working on the space program and now owns his own motorcycle parts business. Is Charlie here? Is he upstairs?
You're doing an interview, right?
I'm doing the interview. What is the name of this place?
Pitbull Products.
Pitbull Products?
Yeah.
Are you Charlie?
Yeah.
Hey, I'm Destin.
Hey,
this guy is Charlie Van Valkenburg. He went to Auburn University as an industrial engineer, and he's got like well over a dozen patents. 20 years ago, he was the lead engineer over the cupola shutter design, but after the project finished, he stopped and went and built his own business. Now he's building this. It's a special stand that uses leverage to pick up a motorcycle so people can work on it. He's so humble about his skills, though, that even the people that work with him had no idea what he did for the space station. When Charlie's team was working on this, they called it Space Station Freedom, which is a really cool name, by the way. This program morphed into the International Space Station program, and Charlie's drawing package was handed over to the Italian Space Agency so the Italians could fabricate it. Charlie, however, kept an entire drawing package because every good engineer knows you might have to go back and look at what you did. We talked about the handles, we looked at the bevel gears, we talked about the cartridge assembly. Okay, we found what might be the most critical part of the entire drawing package. This is the inner shaft, and you can see right here there are 2 grooves, and those grooves are held to within 0.02 of an inch. The reason that's important is because the interface between the inside of that groove and the outer wall that compresses the O-ring, you have to control that because you're taking a circular O-ring and you're going to squish it to an oval. Is that right, Charlie?
That's correct.
There's another detail to those O-ring grooves, right?
Right, these are the dynamic grooves. Those 2 are the ones that actually are turning.
Did you hear what he just said? He said they're dynamic O-rings. That means there's a shaft running through it actually rubbing on the O-ring. So you've got the air that you're breathing as an astronaut, right? And it's being held back from the vacuum of space by 2 little bitty O-rings. That's incredible.